Hey guys, how you doing? It's Mr. Chavla. Um, I'm just here to continue the June 2019 Common Core Algebra 2 exam. So today I'm going over the part 3 questions, numbers 33 through 36. We're almost done, and these were 4 points each. All right, let's go ahead and get started. 33. 33. Hello. Here we are. Okay, factor completely. That's very important, guys. Completely. That means you don't stop until you can't factor anymore. And over the set of integers means no factors, no imaginary numbers. No fractions, no imaginary numbers when we're factoring. So 16x to the fourth minus 81 factors into a difference of squares. We get 4x squared plus 9, which will not factor any farther. And we also get 4x squared minus 9. Now, 4x squared plus 9 cannot be factored any farther. So that we just bring it down. 4x squared minus 9 is a difference of squares. So it's going to factor into 2x plus 3 and 2x minus 3. That is completely factored over the set of integers. All right? Now, Sarah graphed the polynomial 16x to the fourth minus 81, which is the same polynomial, the binomial, and stated all the roots of y equals 16x to the fourth minus 81 are real. Well, let's see. Is she correct? Explain your reasoning. No. 4x squared plus 9, guys, is going to have imaginary roots. We could solve algebraically for the roots. So if we set 4x squared plus 9 equals 0, subtract 9 on both sides, we get 4x squared equals negative 9. Now, you could either take the square root now, or you could divide by 4 on both sides. When we take the square root on both sides, we take the square root of both the numerator and the denominator. I'm going to leave it in red. We need to remember it's plus minus 3 over 2i, or 3i over 2. They're imaginary. So if we were to solve for the other two roots, we would get real numbers, right? If we solve for the other two roots, 2x plus 3 equals 0, 2x minus 3 equals 0. So if I solve the other two, 2x plus 3 equals 0, 2x equals negative 3, x equals negative 3 over 2. And if I repeat with 2x minus 3 equals 0, 2x equals 3, x equals positive 3 over 2. I'm just going to use the slash mark because I was in the way. So, is she correct? No. The roots are x equals plus, I'll write them individually, each one, okay? So it becomes 3 over 2i, negative 3 over 2i, 3 over 2, and negative 3 over 2. We'll just say the roots. We don't have to say x equals. 3 over 2i and negative 3 over 2i are imaginary numbers. So, she's wrong. Not all the roots are real. Poor Sarah. Okay, moving along. So we got the completely factored form. Then we used the factors to find the zeros, 2 of which were imaginary, 2 of which were real. All right, now we're going to move to the next part, 34. The half-life of a substance, radioactive substance, is 15 years. All that means is that it decays by 50% every 15 years. It loses half its mass every 15 years, or half of its amount, however you want to say it, right? Write an equation that could be used to determine the amount, S of t, of 200 grams, the initial amount, of this substance that remains after t years. So I could either put a half in the decimal, or 0.5, or 0.50. I'll just put 0.50 because half is the time it takes for 50% to decay, or half to decay. So it's not to the t power. Remember, if it's every 15 years, we got to put 15 in the denominator. That's how it loses a half every 15 years, half of its mass. If it was every year, then it would be t to the t over 1, which is just t. That's what would be 0.50 to the t. If it lost half of its mass every year, it would be 0.50 to the t over 1, which is just t, if that's 1 year. But every 15 years, it's to the t over 15. Okay, so write an equation that could be used to determine the amount, S of t, of 200 grams, initial amount of this substance that remains after t years, t over 15. So you could put 1/2 in the parentheses, or 0.5 or 0.50. Really doesn't matter. They're all saying the same thing. I just like to think of it as a decay rate of 50% every 15 years. All right, I'm going to minimize me for now. Determine algebraically, it means we're going to have to show work. To the nearest year, that means to the nearest whole number. How long, t obviously, it'll take for 1/10 of the substance to remain. Let's just do this. So we want to see when will S of t equal 20, because 20 is 1/10 of 200. So if I do it, 200 times 0.50 to the t over 15 is equal to, well, if I do this here, just, I don't know if they want us to show that much work. It's 20, right? I don't think that was necessary, but I put it just in case. My equal signs sometimes come out just terribly. So 1/10 of 200 equals 20. Okay, so we want it to be 20. The funny thing though, guys, when I divide by 200 on both sides, 20 divided by 200 will just give me 1/10 all over again. But I'll write it as a decimal this time as 0.10 or 0.1. Alright, so the 200s cancel out, and I get 0.50 all raised to the t over 15 power. I hate that this isn't coming out nicely. I'll just write the decimal like this, the fraction like this. Equals 0.1 or 0.10. I don't know why I got this habit. I like to have the decimals to two decimal. I like to add the 0 at the end and have two decimals. I guess because I'm used to working with percents now, and it kind of just shows 0.50, 50%. Yo! Okay, now here's how it goes. There were a few ways to do this algebraically. You could have used the common log, the natural log, that's ln, or you could use just the log with the same base. And I don't know what kind of calculator I have, but if you're using the log with the same base, the exponent is t over 15 is going to equal log of base 0.50 of, you could either put 0.10 or 1/10, doesn't really matter, of this number. Now, I don't like to round or anything until the end. So if I multiply both sides by 15 so that I get t alone, t is equal to 15 times log 0.5. Yeah, I got lazy. Here, I'll put it 0.50. I'm just not putting the 0 anymore. You don't have to, of 0.10. So I'm going to put that in our calculator. All right, so the funny thing is it's in the graph feature calculator of Desmos and not the actual scientific one where I can do that. So functions, miscellaneous, log with the base I want, log base 0.50 or 0.5, 0.10 times 15, and it's 49.829, which rounds to about 50 years. So I don't know if you have to show more rounding than what they asked. 49.83, let's say. So we'll say, how long would it take? About 50 years, because they said to round to the nearest year. Okay? We could have confirmed in the calculator, but let's, for time's sake, just move forward, all right? Because I saw the key, I worked this out before, it's correct, don't worry. All right, here's the function. All right, you could have put, again, 1/2 in the parentheses instead of 0.50 or just 0.5 in the parentheses, and then it takes 50 years until about 1/10 of it remains, okay? Moving on. Determine equation for the parabola with focus 4, -1, and directrix y equals -5. Use of the grid is optional. Let's use it. So I'm going to draw a little grid. All right, we won't need to use a lot. And you could even use the ruler. I'm being too lazy to pull it out because I don't think it's needed today. At least not for this part. All right, this will give us more than enough space. It was much easier for me to make a horizontal line than the vertical. I spoke too soon. All right, I don't need more than that. All right, I don't need the whole thing. Well, and I realized I didn't split it evenly, but it doesn't matter. We're not even going to use the whole graph. Okay. And let me pull myself up so I'm not just hiding away all the time. Hey. And let me sit up. I'm slouching again. Okay. Focus is 4, -1. That's a point, a single point. And the directrix is a line, y equals -5. So 4, -1 is our focus. Then we're going to get that point. 1, 2, 3, 4. I wish they'd put these grids on the earlier exams. It would have made it much easier. I'm not going to write the 4 because if I do, it's going to block the point out of view. I'll use red for the point. 1, 2, 3, 4. So the focus is 4, -1. And the directrix is y equals -5. I'll use red again. So -2, -3, -4, -5. This is our directrix. All right, I don't even need to draw the whole thing. I'm using red so it doesn't get confused with the x-axis. And this is our directrix. Y equals -5. So our parabola, remember the parabola is the set of all points that is equidistant, meaning equal distant from the focus and the directrix. I'll use blue. So we are 1, 2, 3, 4 units between the focus directrix. Half of that is 2. 2 units halfway between. This is our vertex. Our x value is 4. 1, 2, 3. 4, -3 is our vertex. So I'm going to write that up here. Our vertex is 4, -3. Now, I'm going to use one method. There are a few ways you could do this, okay? One thing you have to know, our parabola cannot cross the directrix. It has to open in the opposite direction, which means it's going to open upwards. That's not exactly how it's going to look like, but this is just a little sketch because they didn't ask us to sketch the parabola, right? There's an equation. So if it goes y equals 1 over 4p. Now, had the parabola opened down, it would have been -1 over 4p, but since it opened up, it has a positive leading coefficient. X minus h squared plus k, where hk is the vertex, p is the distance from the focus to the vertex, or the vertex to the directrix, which is just half the distance between focus directrix, which is 2. So p equals 2. So I'm going to write that in green over here. P equals 2. hk is the vertex. So h is 4. And k is -3. And I'm moving out of the way. K is equal to -3. So if I substitute, it becomes y equals 1 over 4 times 2 times x minus 4 squared plus -3, which just becomes -3. And if I simplify that, all right, I'm going to erase this now, guys, okay? I'm going to erase this because we don't need it. You didn't have to write it. And I'm going to erase this because you don't need this either, okay? Make sure you have it down if you needed it. I'm going to write it again now so that I have space. So we have y equals 1 over 4 times 2. The number in the parentheses is just the distance from the focus to the vertex or vertex to directrix. X minus 4 square is just the vertex form equation, right? But instead of a, we have 1 over 4p as the leading coefficient. Then 4 times 2 is 8. 1/8 x minus 4 square minus 3. And we could leave it like that in vertex form. You did not need to work this out any further. There were other ways you could have done this. This was not the only way, the only correct answer or the only way to do it. There were so many ways. This was one way to represent the answer and one way to get at it, okay? I'm going to move forward to the final question in part 3, which is 36, okay? This is all about focus directrix equation of parabola. So now 36. Juan and Felipe practice at the driving range before playing golf. The number of wins, that's going to be right here, Juan winning or Felipe winning, and the corresponding practice times, which could be short or long, for each player are shown in the table below. Given that the practice time was long, determine the exact probability that Felipe wins the next match. Okay, so whatever's the given, guys, that's your condition. So the way we could say this again is, I'm going to use J for Juan winning, F for Felipe winning, S for short practice time, and L for long. And I'll even add W here for win-win. All right, so whatever's given is going to come last. So it goes probability, given, practice time was long, I'll put L, and Felipe winning. So it's the same as saying the probability that Felipe wins, given that there was a long practice time. The bar in between means given, right here, okay? So the probability that Felipe wins, given that it was a long practice time, is just going to equal, it's going to be out of the total number where there was a long practice time, which if I add them, 15 plus 12 is 27. So 27 of them had a long practice time. So we're only looking at the ones with long practice time because that was the given, L, right? And out of those, how many did Felipe win? Out of those ones only, it was 12. Now we could have simplified the fraction, but it was not necessary. But we don't want to write it as a decimal because they didn't say to round or anything, okay? So it's 12 out of 27, which you could have simplified to get 4/9, but that was all there was to it, guys. Out of the ones that were long practice time, how many did Felipe win? 12 out of 27, okay? Now the next part, determine whether or not the two events Felipe wins and long practice time are independent. Let's do this. If they're independent, then the probability that Felipe winning should be equal to the probability of Felipe winning given long practice time. So the probability of Felipe winning, now here we want the total out of the total numbers. So 27 were long practice time, 18 was short practice time. That adds to a total of 45 games total that they played, right? Out of those, Felipe won. Let me erase the other stuff that's in the way. How many did Felipe win out of those? Felipe won 10 plus 12. Felipe won 22. Felipe won 22 out of 45. This is the amount that Felipe won. All right, I'll just bring that down here like this. In this column we got 22. We could even put this 23, and these also add to 45 if I add these two. So it's 45 total games, either way you put it. Felipe won 22 out of 45 games, right? But remember, we're not done there. Now let's find out if the two probabilities are equal. Felipe winning given long practice time, and just overall probability of Felipe winning. But before we do that, guys, I don't know how to pause this video. I need to put the thing on charger because I thought I'd be able to make it through here before the Charger runs out because it's the last question, but I'm down to 5% and I just realized what a time to have an interruption, huh? And I'm going into the dark side. Bet you never seen a math teacher do like this, have ya? Oh, it's dark here. Dark, 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 dark. Let me get the light on. Oh my goodness. Oh my god. Oh my god, it's dark. It's spooky. It's spooky. It's spooky. Okay, so now, with the light on, let's get this thing done and out of the way. So I'm gonna go into the and I'm forgetting the charger. Okay, I'm back. Okay, 22 out of 45. Now, here's what we're gonna do. I'm gonna find the probabilities as a decimal, just so I could compare them very quickly. I could have gotten the denominators to be the same, but why bother? So 12 out of 27 is the conditional probability, and the other one's 22 out of 45. 22 out of 45. So you see they're not the same, right? They're not that far apart, but they're not the same. One is 0.48 continuously, the other one's 0.44 continuously. So this one is equal to about 0.48. And the 8 just keeps going on forever. And the probability that Felipe wins, given long practice time, is equal to 12 out of 27, which is, and I won't put the bar because I won't put the approximately equal because that's exactly what it's equal to, right, as a decimal. 0.4 just going on forever. That's what the bar on top means. Or it could be 0.44444, right? So they're not equal. So they are, so it said determine whether they're independent. If they're independent, the conditional probability would have been the same. So determine whether or not the two events are independent, Felipe winning, and long practice time. Justify your answer. Not independent, since probability of Felipe winning is not equal to the probability that he wins given long practice time. That's all there was to it, guys. All right. If you have any questions, let me know. Best of luck. I tried to keep this as short as I could. Let me know if you have any questions or any concerns, okay? Any feedback, comments, you know how I go. And good luck, guys. All right, take care. Bye. I'm going to do 37 in the final video.